Hello everyone. So today we're gonna talk about statistic engineering term project, which is about sleep duration. So importance of the sleep duration, there will be three important dimensions that optional sleep duration, short sleep duration, and long sleep duration. So those are one of the most important pillar for this topic. Those are affecting our sleep duration in a short way and also in a long way, in a positive, also in a negative. So the role of physical activity, so there are gonna be three main pillars that exercise and sleep quality, optimal exercise, and balancing exercise and sleep. So in this paper, in this research, we're gonna use some of indicators, some of method to have a look those three dimension with statistic science. So impact of the stress, like as we know, if we will going to sleep like a longer or shorter, it has different kind of effects in our life. So in this paper, we're gonna have a look also this topics. So impact of the lifestyle factors like dietary habits, physical activity level, and compressive lifestyle approach. So those three things has positive effect in sleep duration, and we're gonna also have a look with those things with number.
So our variables include qualitative variables and also quantitative variables. Qualitative ones are the ones that are non-numeric ones, and such as gender, quality rating, and education level are included in the qualitative variables part. And quantitative part, they are numerical data like age, sleep duration, and body mass index. So next up, our code includes charts and graphs like this. So normality test, in our code, p-value was less than 0.05. So our sleep duration variable does not follow a normal distribution. And then our W value was closer to 1. So that means that data are close to normal distribution, but not perfectly fitting it. So next up, point estimation and confidence intervals. Firstly, let's take sleep duration as an example. Average sleep duration was 7.4. So with the confidence interval with 95%, the numbers are shown here, and all of the below ones are the same with the sleep duration part. So our hypothesis test, first hypothesis was, does physical activity affect sleep quality? Our code suggests that the higher levels of physical activity may be associated with slightly better sleep quality, but other factors may also play a role in sleep quality.
And hypothesis 2 is the relationship between stress level and sleep quality. And we see, based on these results, we reject the null hypothesis that the true correlation between stress level and sleep quality is 0. Goodness of fit test and other checks for detecting the distribution. In this section, we examined whether sleep duration and stress level variables comply with normal distribution using the Shapiro-Wilk test and QQ plot. We concluded that both variables were not normally distributed. These findings show that we should use tests suitable for non-normal distribution in our statistical analysis and these variables. Design a linear regression model for us problem, input and output analysis. We have 4 input variables: age, stress level, physical activity, and body mass index. And we have 7 output variables: sleep duration, R squared, p values, age, stress level, physical activity, and body mass index also. In this section, we created and evaluated a linear regression model to examine the relationship between sleep duration and other variables. The conclusion analysis allow us to better understand the factors that affect sleep duration and develop strategies to improve sleep quality by managing these factors.
We conducted an ANOVA test to examine differences in sleep duration across age groups. A high F-value and P-value less than 0.05 indicates significant differences. These analyses help us understand how age affects sleep duration, aiding in making informed sleep adjustments. Let's move on. Application of non-parametric tests. For each test, if the p-value is less than 0.05, it indicates a significant difference between the groups. Test statistic W4-Wilcoxon test and H4-Kruskal-Wallis test support this. Here, the p-value is less than 0.05, showing a significant difference in sleep duration between genders. And last one is clustering k-means. This graph shows clusters by the k-means algorithm, each color representing a different group. People with around 6 hours of sleep have moderate sleep quality. Between 6 and 7.5 hours, sleep quality varies widely, suggesting other influencing factors. Those with 8 to 8.5 hours of sleep report the best quality. The clusters reveal clear patterns in sleep duration and quality. Thank you for attention.